Hi guys, welcome back. It's Mrs. Smith again. So here we're going to keep on trucking in Chapter 8, and we're going to learn all about solubility rules. So let's get started. So solubility is a measure of the amount of substance, or the solute, that can be dissolved in a given amount of a particular solvent at a given temperature. So most of the time we are working at room temperature, 25 degrees C, but it could be any temperature. So these are typically expressed in terms of grams of solute dissolved in 100 milliliters of a particular solution. So to convert to molarity, you have to know what the density of the particular solution is. It is a physical property. For a particular solute, it's a function, again, of the solvent, so it depends on what the solvent is and what the particular temperature is. For gases, the pressure is also included into that calculation. So we have two different types of solutions. One is an unsaturated solution, which contains less than the maximum amount of solute that is able to dissolve. So say, for example, you have a cup of water and you add in a teaspoon of salt, you know you can dissolve more salt in there. So that would be classified as an unsaturated solution. The other is called a saturated solution, which contains the maximum amount of a solute in a given amount of solvent at a given particular temperature. So you can tell that you've hit this point, as you keep adding you keep adding solute, it's dissolving and dissolving, and at some point you're going to reach its saturation point and no more solid can dissolve. So you're going to see it start to crystallize down at the bottom. So that's the only way you kind of really know that you've hit that saturation point. So you see here a solution of lead chloride. You've got the solid down at the bottom. That's the only way that you know that this is a saturated solution. So these saturated solutions involve a dynamic equilibrium between the undissolved solute and the dissolved solute, the solute that's in the solution. So they're always kind of, falling back out, and then the ones that have crystallized are going back into solution. So it's just a constant back and forth with these guys. So the third type is called a supersaturated solution, which actually contains more solute than could be dissolved at a given temperature, but these are generated at an elevated temperature. So that's a little hard to put in the blank here, but it contains kind of more solute than would be expected at a given temperature. These are unstable. And again, you do this by heating up your solution. As the temperature increases with most solids, the solubility increases as well. And then you slowly cool it down. And usually all of that solid will stay in solution. So one way that people are familiar with supersaturated solutions, at least in the South, is when you make sweet tea. When you make sweet tea, you don't just pour sugar into cold tap water with some tea bags. You have to heat up that water to get that sugar to really dissolve into it. So again, that's your kind of introduction to chemistry when you're younger without even really knowing it. So all soluble ionic compounds are strong electrolytes as they dissociate in water, so they form their ions in water. Not all ionic compounds will dissolve in water. We're going to go through that in a little bit. So if you don't have ions, you definitely cannot conduct electricity. So again, compounds that dissolve in water are said to be soluble. Compounds that don't dissolve in water are said to be insoluble. All right. To how much they dissolve just depends on the temperature of the particular solution. And even insoluble compounds, they do dissolve, but just not really enough to do anything. So here we can see a variety of insoluble and soluble compounds. For insoluble, we have calcium carbonate and silver chloride with their respective formulas. You can see that if we have 100 grams of water, and this is at room temperature, we see that we have, about 1,000th of a gram of calcium carbonate that's soluble in water, which gives us a really low dilute concentration. Silver chloride, even less so. So as this 8.9 times 10 to the negative 5 grams are soluble in water. Compare that to those that are soluble. We have sodium carbonate and silver nitrate. You have 7 grams of sodium carbonate that can be dissolved in water. Silver nitrate even more so with 122 grams. That gives us about a 7 molar solution. So it just kind of depends on what the compound is as to how soluble it actually is. So how do you tell if an ionic compound is soluble or not? Well, so we looked at these things called solubility rules. These are empirically deduced that predict whether or not an ionic compound is soluble or insoluble in water. So that essentially means you try it and see if it's soluble, and if it is, you mark it down. If it's not, you mark that down. So it's kind of all over the map. So we do have a set of solubility rules, but in general, the higher the ion charge, the less likely that guy is to be soluble in water. So here we see as we go from sodium +1 to magnesium +2 to aluminum +3. Sodium hydroxide here is the most soluble. Aluminum hydroxide is the least soluble. So here, these attractive forces with that +3 are really difficult to overcome. So he's going to just stick to himself and not interact really with the water. So we're going to go over some just generic observations the next few slides, and then we'll get down to the actual rules. All right, so here, again, this is all probably, most likely, will probably be soluble in water if it contains a cation like the alkali metals. So that's group 1A. So they all carry a +1 charge. So lithium, sodium, potassium, rubidium, cesium, as well as the ammonium cation, NH4+. These all have low charges, +1s, and are most likely to be soluble in water. There will be exceptions, but for the most part, it's a good bet that if it's a +1 cation, it'll be pretty soluble. Again, it is something that will probably be soluble in, and again, we're only talking about water here, if it contains an anion like a halide, so with -1 charges, nitrates with a -1 charge, perchlorates with a -1 charge, acetates with a -1 charge, and sulfate even with a -2 charge. So here, the examples that are in purple are going to be soluble. There are exceptions to these. So with the halides, if you have something that is a silver halide, like silver chloride or silver bromide or silver iodide, probably not going to be soluble. With the mercury cation, not going to be soluble. With the lead 2+ cation, will not be soluble even though the halide is soluble. With nitrates, pretty much everything is soluble. Same with perchlorates and acetates. With sulfates, your +2 cations are going to be problematic. Again, you just got a really strong interaction there. Now, obviously not all +2 cations, but a good deal of them are going to be insoluble. And again, when something is insoluble, that means that it does not dissolve. So again, a compound is probably insoluble, meaning it does not dissolve if it isn't on the soluble list. So we're just going to make that assumption there. So soluble compounds typically will have 1 ion with a small charge, so a +1 or a -1. So very few things that have, +2, -2, +3, -3 charges will form soluble compounds unless they are paired with one of your soluble ions. All right, so these compounds that we've listed here are typically insoluble. So again, they're in that red color to kind of remind you that, hey, stop, they're not soluble in water. So typically things with hydroxides are going to be insoluble. So here we've got lists. The exceptions here are things that would be soluble. So remember, the exception is just opposite of what the rule is. So group 1A cations and ammonium would be soluble. So sodium hydroxide, lithium hydroxide, that sort of thing. Slightly soluble means, not quite fully soluble, but not completely insoluble. So somewhere in the middle. With sulfides, again, group 1A cations and ammonium are going to be the exceptions on everybody. Those are soluble with everybody. And again, some of your group 2 cations will be soluble with sulfides. With carbonates, again, and with phosphates as well, with these high charges, you just have to have the +1 cations to counterbalance that, and that will make them soluble. Other than that, everything is insoluble. So we have summarized these nicely into a pretty little table. So again, it's just, is it soluble, and where the exceptions are. So if it's in the soluble category, these exceptions here are going to be insoluble. If it is in the insoluble portion, these guys would be soluble. So keep that in mind. All right, so let's test out a few of these compounds and look at the solubility table and determine whether or not these particular ionic compounds are soluble or insoluble. So first is zinc chloride. So check out your table, see what you think, and then we'll talk through it together. All right, so here we can either break it down into what the cation is or what the anion is. We don't have any particular rules for zinc, so let's look to chloride. So chloride here is halogen, so we're going to look only to this row here. This is in the soluble category, and the only exceptions we have are silver, mercury, and lead. So zinc is none of those, so it's probably a good bet that zinc is going to be soluble in water. So again, using the table is not that hard. You just have to know kind of how to read it. All right, next up we have sodium sulfide. So again, look at the table, see what you can come up with. All right, so again, we can look. So here we have sodium and sulfur, or sulfide, are both on this list. So sodium here is in the soluble category. Pretty much everything with sodium is soluble. So it's a good bet that this guy is going to be soluble, but we can also check down here with the sulfides. We see that sulfides are generally insoluble, but the main exception is group 1A, which sodium belongs to. So either way you looked at it, this one would be soluble. All right, last but not least, we have barium sulfate. So again, dive into the table, see what you can come up with. All right, so we don't have any basic rules for barium, but we definitely have one for sulfate. So sulfate is in the soluble category, but it has a lot of exceptions. So let's take a look at those exceptions. So we have silver, mercury, lead, calcium. Oh, look, there's barium. So that means barium sulfate would be insoluble. All right. So if it's in the soluble category, but it's in the exceptions, that means it's insoluble. If it's in the insoluble category, but it's an exception, that means that it is in fact soluble. So again, just kind of earmark this table, write it down, copy it down, whatever you need to do. But it is very good to have on hand, especially when we go to the next section, which is talking about precipitation reactions, where you're going to have to predict solubility. So just keep an eye out for it. All right, thanks guys. Have a good day.